So in the previous videos in this section of the course, we looked at reading and writing data using character streams. To write out the data, we used the FileWriter class, and to read it back in again, we created FileReader objects. We then discussed the idea of buffering the stream so that large chunks of the data are read into memory by a buffered reader. Now this prevents excessive access to disk because the data is only read from the disk when the buffer is empty. Otherwise the file reader continues to take data from the memory buffer, so it's much more optimized compared to just sort of reading a character at a time. Now you can also buffer data when it's written to disk, and not surprisingly this makes use of a buffered writer class. The concept is the same. The file writer puts data into the buffer and the data is only written to disk when the buffer is full. Now once again, this prevents writing small amounts of data to the disk, which is very efficient because a disk drive, generally speaking, is much slower than your computer can process. So your computer application is going to be slowed down waiting for that disk drive to write data. So by doing it this way, using a buffered writer, data is written in sizable chunks rather than sort of a character at a time. Now I didn't actually use a buffered writer in the previous example, and I only used a buffer reader to write the directions file. The data from the locations file was read from disk line by line, and that resulted in many accesses to the locations.txt file. So in the next few videos, I'm going to cover byte streams, which write binary data rather than character data to the streams. And it would make sense, though, to have an efficient program to modify. So I'm going to start off with a challenge. So first, I'm going to remove all the commented out code to help tidy things up. So we've got a good basis to start with. So let's start just commenting some of this stuff out. So we'll go to locations. And remember that in the locations Java file just above the static initialization block, we have this code here. So let's just delete that to clean things up a little bit. And just scrolling down, we also have this code in here when reading the exits. Let's just delete that as well, just to make things like a little bit cleaner. And we've also got this code down here, which we can also remove. And that was our initial code to have directions, locations, and exits before we decided to start writing that to a file. So I'll delete that as well. Okay, so that's looking a little bit better. Okay, so here is the challenge. So I'm just going to make that a little bit bigger so we can see what this is all about. And there's two parts to this challenge. So part one, we're going to modify the program so that it uses a buffered reader to read in the locations data. So we run the program to test it before moving on to part two. So that's part one of our challenge. Now part two, we want to then modify the main method of the locations class so that it uses a buffered writer to write the data. So open the locations.txt and directions.txt files to check that the data has been written successfully. That would be your way to make sure that using the buffered writer that it does work. And you'll then need to make another change to the program to allow for the quit exits before using the newly created files. And just as a hint here, you may want to change the 3 instances of HashMap to a linked HashMap in the location class and 1 instance in the locations class so that you can compare files more easily. And the reasoning for the zero quit is that when the data was originally written to the files, it's been hard coded in the locations class and there were no location zeros because this is added by the location class constructor. But now that we're writing the contents of the class to the directions.txt file, the 0 locations will also be saved, and that's why a change will be needed to allow for this. And this is that part here that I'm talking about, the 0 quit exits before using the newly created files. Alright, so that's your challenge. Go away and see if you can figure that out now for this code. And once you've had a go at it and you think you're ready to see what we've come up with, come back and we'll go through that code. So pause the video now. Okay, so how did you get on? Hopefully you managed to get it working or gave it a pretty good go. So let's go back now and get this working. So part one, and just as a recap, part one was to modify the program so that it uses a buffered reader to read in the locations data. And we're going to make that change and then we're just going to run to make sure things are working before we move on to part two of the challenge. So to implement the first part, we really just need to make a relatively simple change in the static initialization block in the locations.java file. So where we've got this try scanner equals new scanner, the new file reader, we really just need to change file reader to a buffered reader. But we put the new buffered reader in here, so new buffered reader, then we put the new file reader in there, then we add another bracket. So that's really all we need to do. So we now just have just changed it. So we've added the new buffered reader, which still takes the file reader as input, but now the data will be read using the buffered reader, which is obviously more optimized to read in chunks rather than reading a character at a time. So let's go back to main. We'll just run this to make sure that it still works. And there's a location, so we can try topping up, down, east, west, west, east, west again, northeast, north, and quit. So that seems to be working all right now. So let's move on to part 2 of the challenge. So part 2, we want to modify the main method of the locations class so that it uses a buffered writer to write the data. And then we want to check the locations text and txt and directions.txt files to check that the data has been written successfully. And then, as I mentioned, we need to make these changes to allow for the 0, the quit exits before using the newly created files. Okay, so how do we go about that? Well, let's look at location. Now, at the moment, you can see that we're using a map. Our definitions for map for exits, for example, here on line 12, and you can see that we're using, for the exits, ultimately we're using a hash map. So for part 2, it's going to be really useful, I think, to compare the newly written files with the big locations and directions files. And to that end, it would be really useful and helpful if the data was written out in the same order as we read it in. Now, although this is not really necessary for populating our locations and exits map, it will make comparing the files a lot easier. Now, at the moment, we're using hash maps, as you can see on the screen there, and they have no guaranteed ordering of their keys. And that's why in the hint, I sort of mentioned a linked hash map and suggesting that you use those. And the reason for that is the ordering will be the order that the keys were added to the map instead of just hash map, which is, again, no guaranteed ordering of their keys. So to achieve that, it's relatively simple still. We come back here where we've got this code if exits is not equal to null. So we change this .exits equals new, and we change that to a linked hash map. Linked hash map. And we'll do the same for the next line as well. And then going down to the getter, instead of returning a new hash map, we want to return a new linked hash map there as well. So that's really the only change we need to make in location, but we also have to go back to locations.java. So let's go and have a look in there. And we need to make a change in there as well to use a linked hash map. So at the moment, you can see here on line 12, we're using a hash map. So let's change that to a linked hash map. And now within the main for the locations class, we need to make some changes in here as well, but they are fairly simple as well. So the change we need to make here is we're going to create a buffered writer. So buffered writer, and we'll call that one lock file, is equal to new buffered writer, and there's going to be a new file writer within that as the input. We need to add a bracket to make it valid. Then for the next line, we want to do the same thing as well. We're going to put buffered writer, and we'll call that dir file equals new, and it's going to be buffered writer, and it's going to be new file writer again. Then we need to add another bracket. And that should be all we need to do. All the other code there is going to be the same as what it was before. We don't really need to make any other changes. So we want to run this program, making sure we're running the main within locations. So let's just do that. Run locations.main. Okay, so that's finished. And then what we want to do is we want to make sure that the locations and locations_big.txt are now identical. So let's just have a look at that. So locations.txt, the one that we've just written out, and locations_big. And let's just close down this run window so we can see a little bit more. So there's locations_big, which already existed, and then locations.txt, which was the one that we've just created. And if we just scroll down randomly to have a look, it seems to be pretty good, but we'll just double check. 42. Looks pretty well identical. We'll just scroll down to the bottom, making sure we've got right to the end. And location 140 is the last one. Location 140 dead end. So I think that's pretty much identical. From my point of view, that looks pretty similar. If there's something different, I can't see it from a from a look now anyway. So it looks like we've done the right thing there. Now, if we close down these locations to location files, and we have a look at our directions_big, and directions.txt, there are extra entries for the quit option, and we've added those with this code. And they've now been added. So directions_big has got only one, it starts on location 1, but directions.txt, we talked about that 0. Extra entries for the quit options, 1 for each location. Now there's 2 ways to deal with this. We could either stop the location constructor from automatically adding the quit exit, or we can change the code that writes out the data so that it doesn't write out any Q keys. And as is usually the case when programming, there's pros and cons to both approaches here. So if we prevent the location class from automatically adding the quit option, we're cluttering the data file with entries that really aren't part of the game, and there's a risk that someone editing the files may forget to add a quit option for any new locations that they create. But if instead we change the program so that it doesn't write out the quit exits, then there's really no need to remember to include them in the data file. But then of course we lose the ability to have quit do something slightly different for certain locations. For example, if we wanted to add that functionality. So if the player had been lost in a maze for a long time, for example, you may want to offer them the chance to be taken out of it in exchange for some of their treasure if they quit. So for my solution, what I'm going to do is change the main method so that it doesn't write out location 0. So let's go back and do that. So back in locations.java. So at the moment we've got the code there, and you can see that we're looping through, and we're using that for loop there for the directions, and we're just writing out everything. But what we need to do to ensure that we're going to miss this the quit option, we're basically going to add an if comparison there. We're going to put if not direction dot equals, we'll use ignore case to make sure if it's lowercase q or high case that we're still testing it. So then only if we're not, we haven't got the quit as the direction, as the option I should say, then we're going to write that out. So once we do that, we should now find that the directions file is identical. So let's just run this again. Run locations.main again. And then let's have a look at directions.txt. We're now starting with 1 this time, and that's obviously identical to that. So if we just scroll down and look down to the bottom, 396 is the last line, 396. So basically we've got identical outputs from both. So that's good that we fixed that. Now there's actually a third way that we could deal with that issue, and what we could have done is we could have completely removed location 0 from the exits maps and dealt with the quit option by then checking the user input in the main game. That would slightly complicate the code, but it would save the memory used to store all those extra exits. Now the memory of course isn't a big issue with our 140 locations, but with that said, it's always a good idea to consider all the options before settling on a particular solution. So that's the end of this challenge, and we've now seen how to buffer both input and output. In the next video, what we're going to do is we're going to start looking at writing binary data using byte streams rather than the character streams that we've been talking about today. So I'll see you in the next video.